Okay, so finally we get to XOR, which is over here on the right. We just did OR, which is linearly separable, and we did AND, which is also linearly separable. That is, you can separate the blue dots from the green dots, basically. The sets of points that have value 0 from the sets of points that have value 1 in each case. But over here you can't. And so let's make sure we understand. XOR, X stands for exclusive. And so what you're asking is either Anne or Betty home, but not both? I want to make sure that just one and not the other is home. But it can be either one or the other. And so when neither are home, then that's 0. You know, the answer to that is it's not the case that either Anne or Betty are home and not both. But if Betty is home and Anne is not, then the answer is yes. If Anne is home and Betty is not, then the answer is yes. And if they're both home, the answer is no. So it's a 0. Now the question is, of course, can you draw a line between just a single line to separate the green dots from the blue dots? And the answer is no. There's just no way to do it. And in this space as it's been created. So XOR is, of course, not linearly separable. Okay, and that'll become somewhat interesting when we look at the limitations of elementary perceptrons, just single little baby perceptrons. All right, got to tell you about this nasty error on page 91. Okay, and I don't know what this thing is. Let's get rid of that. Hey, I don't know what's going on. Anyways, somebody tried to make a table, a truth table for P or Q. Now there are different ways of doing truth tables. If you took a logic class here or anywhere these days, you probably didn't set up the truth table with the P and the Q on both sides of the OR for the table itself. Usually what we do is we have the P and the Q here, and then that's the inputs, and then you have the answer for P or Q to the right. And you'll see a version of that on 91 at the top, which I haven't replicated here. But at the top of page 91, they do it in that other way. But here what we do is we put the inputs on this side and on this side, and then the answer goes here. So when P is 1 and Q is 1, P or Q is 1. And when P is 0, Q is 1, P or Q is 1. But of course, here they mess it up. This should not be a 1. It's just an error in the book. This over here is the correct table. So continuing, when P is 1 and Q is 0, then we're doing, by the way, we're doing OR, not exclusive OR. We're doing OR. Then you get a 1. And then when they're both zeros, you get a 0. So this is what you should be seeing on page 91. But unfortunately, this is what's actually printed.